In this video we are again looking at skew lines. This time we're going to find the shortest perpendicular distance between two skew lines. So just a quick recap, skew lines are lines that do not intersect, nor are they parallel to each other. To determine if lines are skew lines or if they intersect each other, where they appear to cross each other, if they appear to cross each other in the same position in plan and elevation, then they are intersecting. Here this line would intersect here somewhere. That is not the same position that it intersects in or appears to intersect in plan, so these are skew lines and do not intersect. So the start of this question is the same as what it was for the previous one that we do. We again need to find a horizontal line in the elevation. So I'm going to take a line that is parallel to CD. So I'm going to create a plane basically that has a horizontal line in it and a line parallel to the other line. So this is going to be parallel to this one, and I'm going to create a horizontal line now from B to come across and meet that. So my horizontal line is this one. I need to find that same line in plan, so I took a line parallel to CD and I put it onto A. So I need to do the same thing here. So a line parallel to CD from A, and I need to find my point P, which is at the end of the horizontal line, and project that and find that point now in plan. So this is point P, and that is going to join back to B because it joins to B in the elevation. So this same blue line is this one here now. What we know about this line is because it's horizontal in elevation, it is going to be a true length in plan. So what I'm going to do next is I'm going to look along that true length line. So I'm going to take find a point view of it. So looking along the line here, all points are going to be projected along it, and I'm going to find a line perpendicular, which will be my x1, y1. Each point needs to be located out here in space, so I'm going to project each of the lines A, B, C and D out. This is the same as we do for the finding the shortest horizontal distance. Each of this is still the same so far. So A has a height of 5 mil as we're given in the question. D has a height of 25. B has a height of 20. And C has a height of 55. So marking these out here, they give me two lines that appear to be parallel to each other. And that gives me those two lines there. So these are parallel to each other in this view, and I have my x1, y1 line. So the next part here is the only difference that we have in the construction and finding of finding our shortest perpendicular distance and the shortest horizontal distance. So previously for the shortest horizontal distance we just looked in horizontal. We looked in parallel to the x1, y1 line. Now as we need to find the shortest perpendicular distance, we are going to look in perpendicular to our two skew lines here. So we're going to look in perpendicular to the skew lines here. That's how we're going to solve this. So if it's shortest horizontal distance, you look along the x1, y1 line. If the shortest perpendicular distance, you look perpendicular to our two skew lines. So looking perpendicular to this, our x1, x2, y2 line, is going to be parallel to the line AB and the line CD. So they're going to be drawn out here. This is an x2, y2 line. Each point is going to be projected out perpendicular to that. So D is on this one, C, B and C. And the distances out each of these are taken from our previous view. So we're working this one, we're skipping the auxiliary elevation, and we're going to take our distances from the plan, working from the XY line, X1, Y1 line back. So measuring our distances with the compass, so from our X1, Y1 line back to D, and putting that same distance up here. This is D. For A, again measuring from the X1, Y1 line back to A, and from the X2, Y2 line, this is point A. From X1, Y1 back to B, finding that same line off of it over here. That's B, and X1, Y1 back to C, and finding that out here. So this is C. A as always is joining to B in this question. C joins to D, and they now appear to cross at this point here. So what we're going to do, we're going to, the rest of the constructions here are now, that's the same. We're going to project our lines back from where they intersect here. That's going to give me the shortest perpendicular line between the two. So taking this line here and projecting this line back down. This line is the shortest perpendicular distance. This is perpendicular to both. So 90 degrees here and 90 degrees here. We need to find these lines now back in the plan and the elevation. That is done the same way as we found points up there in the first place. So we're going to take our lines and project them back. So looking along our true length line again, this one intersects the line AB. So that's that point there. This intersects the line CD. That gives me this point here. So our shortest perpendicular distance in plan is this line. And finding the same line up in the elevation, so you can project your height or line straight up. And what I'm going to do is I'm going to take the heights from my X1, Y1 line. So taking my height here and just marking that up into the elevation. So that height applies to the line CD. So that gives me that point, which is directly above the one here in plan anyway. And I'm also going to do, for the line AB, doing the same thing. AB, and I'm just going to mark that up to get that height. So you can just project your line straight up if you like. So they appear directly in line with each other anyway. So one way or the other way, doesn't matter which one. And then this is the shortest perpendicular distance in the elevation. So this is it in plan. This is the shortest perpendicular distance in elevation. What we've done is we've found a horizontal line. We've created a plane with one side of that plane parallel to the other line. We've put a horizontal line in there, and we've had our second skew line. We found those same lines down in plan. So this is parallel to this. That's the same point P. This gives us a true length. We're going to look along that, but this time instead of looking along the X1, Y1 line, we're going to look in perpendicular to the planes, or to the skew lines AB and CD. Looking in perpendicular to them, that'll give us the shortest perpendicular distance up here in our second auxiliary, and we can project all of those back. So that gives us the shortest perpendicular distance.